Ottawa City Administration Education Bureau in collaboration with Addis Media Network. I'm Teacher Mamu. Today we will start our discussion on the fifth unit, okay? So the fifth unit is about theorems on triangle, okay? Unit 5 is about theorems on triangles. Okay, so under this unit, there are three major subtopics, okay? There are three major subtopics. So the first subtopic in this unit is about the angle sum of the interior angle, the interior angle of a triangle, okay? So 5.1 is about the sum of the interior angle of a triangle, okay? Before I proceed to the topic, I want to remind you some very important concepts from your previous grade level. If we have two parallel lines, okay, you all know that parallel lines are a line that never meets, and a transversal line, okay, say this is a transversal line, the line that cuts the two parallel lines. There are some important terminologies that you need to understand. Interior angle, vertically opposite angles, okay? So if this is A, B, C, D, E, F, G, H, okay? If you see this thing, A and B forms supplementary angles, right? Supplementary angle refers to the sum of the angle whose result is 180 degrees. Okay, two angles are said to be supplementary if the sum of the two is 180 degrees. The other thing is, so A and B can form supplementary angles. The other thing is A and D are called vertically opposite angles. Okay, always vertically opposite angles are congruent. Similarly, B and C are also vertically opposite angles, right? But if I take D and E, these are alternate interior angles. They are congruent. C and F are also congruent, right? So this happens whenever you have a parallel lines and transversal, right? So let's see the first theorem that we have in 5.1. It's about the sum of the interior angles of a triangle, okay? Theorem 5.1 is, Theorem 5.1 tells us the sum of the interior angles of a triangle is 180 degrees, right? You all know this thing. Here, I will show you how this fact can be derived, right? For any triangle, the sum of all the interior angle must give us 180 degrees. You may know this thing, but here I will show you how we can derive the result. Okay, so consider this triangle. Consider triangle ABC. Say this is A, B, C. These are the vertices. Okay, say the angle here is B, small b. Angle here is small a. Say this is C. Okay, this small letter represents angles, right? Now construct a line passing through the vertex A, which is parallel to BC. Okay, we need to construct a certain line passing through A in such a way that that line should be parallel to BC. So if you do that, you can roughly assume this is a line, L1, which is supposed to be parallel to BC. If this construction happens, you can see that BC, if you extend here, BC can be a transversal line for line L1 and BC, right? Okay, this is, say this is L1, I mean L2. Okay, you can say L2. L2 is a line containing BC, and L1 is a line passing through the vertex A. We are assuming that L1 and L2 are parallel. Now, our objective is we want to show, I use this letter, we want to show, okay, it's a shorthand notation that I used to represent, we want to show that angle ABC is, angle A plus B plus C is 180 degrees. Because these three angles are the interior angles of the triangle ABC. So to prove that fact, let us consider the angle between the line L1 and BC. Say that angle is D, and assume this angle is E. Okay? Now, if you are considering L1 and L2 as parallel lines and BA as a transversal, this angle D and angle B are the same, right? So angle B is congruent to angle D. Okay, these two are congruent by alternate interior angles, right? The reasoning is by alternate interior angles. The other fact that we have here is, if you consider AC, okay, AC as a transversal line for the two parallel lines, then we observe that angle E and angle C are congruent. Angle E and angle C are congruent by the same reasoning, by alternate interior angles are congruent. Now, let us add all these three things, okay? Add angle A, I mean angle D, plus angle A, plus angle E, okay? Clearly, the sum of all these three gives us a straight line, and you all know that a straight line forms 180 degrees, right? So these three angles sum up to 180 degrees. So you know that D is the same as B, okay? In place of angle D, you can substitute B, okay? Substitute B. Just put angle A as it is. And in place of angle C, you can substitute, in place of angle E, you can substitute angle C because they are congruent. So here, in place of E, I can substitute angle C. This must be 180 degrees, right? You can rearrange this thing in any order, okay? Addition is commutative, so you can write these three things in any order you like. So this implies angle A plus angle B plus angle C is 180 degrees, which is the required result in theorem 5.1. So this is why we say that the sum of the interior angles of any triangle is 180 degrees, right? Well, if you have the understanding of this sum of interior angles of a triangle, you can answer any question regarding the interior angles of a triangle by using this fact. So let's see some examples. So let's see the first example. In the figures below, find the value of x. Okay, so the figures are, one of the figure is, say, a triangle with this one is 35. Say this is 65, and this is 2x. The other triangle is a certain right triangle. Here, its degree is 30 degree. We don't know this angle. Say this is x. The third one is a certain equilateral triangle with x degree. Okay, equilateral means all the sides are congruent and all the angles are congruent. So, if you are asked to find the value of x in all these three cases, we need to apply the theorem 5.1, or the theorem that says the sum of the interior angles of a triangle is 180 degrees. Okay, this is the only thing that you can apply to find the unknown variables in this case, right? So, whenever we take the first triangle, the angles are 35 degree plus 65 degree plus 2x must be something. What is that number? The sum of all these three things, based on the previous theorem, the sum of all these angles must be 180 degrees. So we can now add these things, 35 and 65. The sum of these two is 100. Okay, 100 degree plus 2x is 180 degree. So collecting like terms, this gives us 2x is equals to 180 degree minus 100. So this implies 2x is 80 degree. Now you can divide both sides by 2. Okay, make it over 2 over 2. Then x becomes 40 degree. Okay, the value of x in the case of the first triangle is 40 degree. You can check that 2 times 40 is 80, right? So the whole this angle is 80 degree. Okay, the interior angle of this triangle is 80 degree, and this one is 35, and this one is 65. The sum of all this thing must give us 180 degree, right? After you calculate the value of x, you have to check that the sum of all these three must be 180 degree. If it is not, there is something wrong on the procedure that you followed, right? Always don't forget to check your answer by substituting the value of x, right? Good. Now when we come to the second triangle, in the second triangle, this symbol is a symbol that we usually use to represent 90 degree, right? So if there is this kind of symbol, don't expect some numbers here. Okay, by default, if these two forms perpendicular to each other, then the angle between the two sides is 90 degree. So roughly you have 90 degree. So the sum of all these three must be 180 degree, right? Or the sum of the remaining two angles must be 90 degree. You can use either of the two ways, right? So x plus 90 degree plus 30 degree is 180 degree. So the sum of these two is 120. So x plus 120 degree is 180 degree. Then transforming 120 to the right side or subtracting 120 from both sides, you will have x becomes 180 degree minus 120. So this difference is 60, okay? 60 degree, okay? The value of x in the second triangle is 60 degree, right? When we go to the third triangle, in the third triangle, it's given that the triangle is an equilateral triangle, meaning that all the sides of the triangle are the same. That means, by default, if all the sides of the triangle are the same, the angles of each interior angles will be the same. So you will follow the same procedure. The sum of these angles, x plus x plus x, must give us 180 degrees. So this sum is 3x, right? 3x is equal to 180 degrees. Now you can divide both sides by 3. Okay, divide both sides by 3. Then x becomes 60 degrees, right? So this is how you calculate the unknown variables or the unknown angles in any triangle. Okay, so this is the first example. Let's proceed to the second example. In the figure below, find A, B, and C. Okay, here is the figure. There is, okay, say this angle is, say this is 55 degrees and this is 25 degrees. Okay, one of this angle is 55 degrees and the other is 25. Assume this is angle A. Say this is angle B. And C here, here 65. Okay, here in this figure we have two triangles joined at some point here. Okay, so from this figure you are asked to calculate the value of A, B, and C, right? So you need to follow the theorems that we used in our previous example, right? So consider only this part, only this triangle. The sum of these three angles must be 180 degrees, right? So you have to write A plus 25 degree plus 55 is 180 degrees. Okay, you can ignore the other parts of the triangle and consider only this part, right? So whenever you do this, you will have the value of A. So let's see what A looks like. 25 plus 55 is 80, right? So A plus 80 is equal to 180 degrees, right? Now, transforming 80 or moving 80 to the right side, the value of A becomes 180 degrees minus 80 degrees. And this difference is 100, okay? Therefore, the value of A in this figure is 100 degrees, okay? Now, we can go to the next part, okay? But to find the value of B, always you need to think of these two angles, okay? If there are two lines intersecting at some point, these two are congruent, and we call it vertically opposite angles, right? Vertically opposite angles are congruent, right? So, for example, if this is 70 degrees, the remaining part, because it forms 180 degrees, the remaining part becomes 110 because the sum of a straight angle is 180 degrees. Again, this is also a straight angle. If this is 110, the remaining should be 70 because it has to form a straight angle and the result is 180 degrees. So this should be 70 degrees. And we call this angle vertically opposite angles. At the same time, this and this are also similar. Okay, so from the figure, we don't calculate anything for B. we apply the concept of vertically opposite angles, right? A and B are, angle A and B are the same. They are vertically opposite angles. Now we have B, we have A, what is left? C. Okay, to calculate the value of B, you need to consider, ignore the first part of the triangle from the figure, forget this part, and consider only this part of the triangle, okay? So the sum of these interior angles must give up to 180 degrees. That means B plus C plus 65 is 180 degrees, but B is already known, B is 100, so 100 degree plus C plus 65 degree is equal to 180 degree. Well, now you can collect like terms. 100 plus 65 is 165. This must be 180 degree. So now, taking 165 to the right side and subtracting, so C becomes 180 degree minus 165 degree, and this difference is 15, right? Therefore, angle C is 15 degree. Okay, so this is how we calculate the unknown variables. Now let's see another example which is a bit different from what we have seen so far. Okay. If the interior angles of a triangle, if the interior angles of a triangle are in the ratio for 5, 6, find the interior angles, the interior angles. Okay, this example is a little bit different from what we have seen before. Here, what is given, the ratio of the interior angles of a certain triangle is given. That ratio is 4, 5, 6. So having this information or using this information, you can calculate the interior angles of the given triangle, right? So usually ratios are given in the least simplified form. So we convert that simplified form into original form in this way, okay? 3, 4, 5, 6 is equivalent to 4K, 5K, 6K, where this K is something different from 0 and positive, right? It should be a number bigger than 0, so that this least simplified form can be converted into its original form. Assume the original values of each angles are 4K, 5K, 6K, right? Now this 4K plus 5K plus 6K must give us 180 degree, right? The sum of all this interior must be 180 degree. Now add this thing. The sum of all these three is 15K is equal to 180 degree. Okay, now you can divide both sides by 15. So K becomes some amount, 180 degree by 15. Okay, whenever you divide 180 degree by 15, the result is 12, right? The value of K is 12. K is equal to 12. Now, we have the value of K, okay? So the interior angles can be converted into their original form. Okay, one of the angle is 4K, okay? 4K means 4 times 12, which is 48 degree, okay? One of the angle is 48 degree, and 5K is 5 times 12, which is 60 degree, right? And 6K is 6 times 12, which is 72, right? Now, we have already answered the question. We are asked to find the interior angles of a triangle where the ratio of the interior angles are in the ratio for 5, 6. Okay, now you can check whether our answer is correct or not. These are the 3 angles, the 3 required angles of the triangle, right? As you can check, the sum of all these 3 must be 180 degree. If the result is different from 180 degree, the answer is wrong. So you need to check that 48 degree plus 60 degree plus 72 degree is 180 degree, right? This is one of the things that you need to check. The other thing is the ratio of these 3 angles must be 4, 5, 6. That means if you write this thing 60 by 72 by, no, the first one is 48. 48 to 60 to 72, right? So if you write this thing in the least simplified form, 48 means 4 times 12. 60 means 5 times 12, and 72 is 6 times 12. Always, whenever we write something in the form of ratio, we need to write in the least simplified form, so we avoid these numbers. So clearly, as you can see here, the ratios are given in the form 4, 5, 6, which is the same as what we have here. So we have checked both things, right? The sum of the interior angles are 180 degree, and we have checked that these 3 angles are in the ratio 4, 5, 6. Okay? So now I will give you one more example, and that will be the end of our discussion for today. Okay. Okay. In this example, if the interior angles of a triangle are 3x, 4x, and 5x, find the largest angle. Okay, here there is a certain triangle whose interior angles are 3x, 4x, and 5x. So based on this information, we are asked to find the largest angle, okay? To answer this question, you need to follow Theorem 5.1, which deals about the sum of the interior angles of a triangle, nothing more. So here we need to add all these interior angles, 3x, 4x, and 5x add up to 180 degree, right? So these are like terms. 3x and 4x is 7x. 7x and 5x is 12x. So 12x is equals to 180 degree. Now dividing both sides by 12, you get some value for x. Okay, make sure that 180 degree divide 180 by 12. The result is 15. Okay, so x is 15 degree, right? Now we have the value of x. The next thing, to find the largest angle, you need to substitute the value of x and list out all the three angles. Then you can pick the largest of the three, right? So one of the angles is 3x, okay? 3x means 3 times 15 degree. This is 45 degree. The other one is 4x. 4x means 4 times 15 degree, which is 60. And the third angle is 5x, which is 5 times 15 degree. And 5 times 15 means 75 degree, right? So these are the interior angles, okay? So before you find the largest of these three, you have to make sure that the sum of these three things must be 180 degree, right? I will leave this checking for you to check whether this three is add up to 180 degree or not, right? Now we are asked the largest. Clearly the largest of these three is 75 degree. If you are asked the smallest, your answer would be 45. But for the time being, we are asked the largest angle, so your answer will be 75 degree. So far in this lesson, we have seen how we can find the unknown angles of any interior angle of a triangle. And using different scenarios, we were able to find the unknown angles for a certain triangle. And if you have the ratio of any angles of the interior angles of a certain triangle, you can find the interior angles of each one. So this is all about for today. I hope you enjoyed the lesson. Thank you for listening.
They glide through the water with unmistakable grace.